Okay. First of all, hi. And I wanted to start off by letting you know a few of my thoughts. Here's my first thought. I was like, they need to see me while they're listening to this. And I don't want to be on the video. So I typed in hot male teacher, and this is the picture that came up. So apparently, this is, America's image of what an attractive male teacher looks like. So, just visualize this guy as I'm going through it. Here's my thoughts. We're going to be out for quite a while. I would imagine at least until after spring break. And then when you come back, I imagine you're going to be bombarded with a lot of testing from teachers and people trying to catch up. And so my thoughts are, trying to keep your stress levels down and my stress levels down and still accomplishing what we set out to do in the beginning of the year, which is to be successful on the AP exam. So things aren't all that bleak. First of all, as far as labs go, hey, I'll write in the word labs like I'm doing something here. As far as the labs go, we've completed all of the required labs except for three. There is a KSP lab that goes with Chapter 16, and then there are two labs for Chapter 18, and one of them is a spontaneous electrochemical reaction called the galvanic cell. And then there is one where you hook the thing up to a battery and you run the reverse reaction called electrolysis. And even though these are required labs for college credit, I wouldn't say they're essential labs. I mean, they're not things that come up very often on the AP exam. So it's the sort of thing that I think that we can do in May after the AP exam. Again, just to make sure that if you're submitting your work for college credit and you don't want to have to retake the class, that you get the college credit. So I'm not worried about labs. As far as the chapters go, the required chapters, um, wow, that is awful. That is not the word required. That is, okay, that's supposed to be required. Chapter 16, um, we've completed, which is the KSP chapter. And then we have chapter 17, which is the second part of thermodynamics. Eh. And it's thermodynamics with an equilibrium component to it. That's why they separate the two in the first semester and then they throw this in the second semester. And then chapter 18 is electrochemistry. And then the things that we would like to do, which I'm going to call luxury chapters, are chapter 19 on nuclear chem, chapter 22 on organic chem, and chapter 21, which is the ligands for the Lewis acid base. Um, and I normally assign chapter 19 and chapter 22 for independent study. And we'll just have to see how things go. So, what I'm saying is, things aren't as bad as what you might think in terms of us getting through things because we were just about finished anyway. My biggest concern is testing, how to do that. And I have something I'm planning, and I just have to work out the software. My issue with cheating on tests when you're doing this soda, by the way, is that, look, as far as cheating goes, if I was somebody who wasn't cheating and I got a lower score than somebody who cheated, that sort of contempt I have, I wind up taking out on the teacher rather than the person cheating, and it creates some issues of trust between me and students. So I really don't like it when somebody gains an advantage over an honest student by cheating. Um, but I think online testing is going to be fraught with cheating, and what I have to do is establish some way of at least trying to curtail it. Um, it's sort of like car alarms. I mean, a car alarm isn't going to stop a thief from stealing a car. What you hope is that if a thief sees that the car is alarmed, that they'll move on to a different car that doesn't have an alarm. And that's really what I'm going to try to do, is try to set up something where, yeah, I know that if you work hard enough, you can defeat it and cheat, but I'm going to at least put some sort of car alarm on it, and I haven't devised all that yet. All right, so I'm kind of testing this screencast thing. So I'm going to start with last week. The problem that we left off with last was this KSP problem that involved selective precipitation. And I said that those problems were pretty difficult. First of all, just to remind you of the question, they give you a mixture of magnesium and calcium salts, probably magnesium nitrate and calcium nitrate, since all nitrates are soluble. And they're spectator ions, the nitrates, so they don't affect the position of the equilibria. And they give you the concentrations of the magnesium, the calcium ions in there. And they ask you to calculate the OH minus. What they probably would ask you to do once you get the OH minus calculation is actually to calculate the pH, would be more of an AP style question. And I went through it and I said, look, first thing you do is you take the system that has the lowest value for the KSP. This was the magnesium hydroxide. And that's the one that's going to precipitate first, and that was correct. If we define the solubility, we would say that X is equal to the magnesium concentration, and 2X is equal to the hydroxide concentration. If we had a normal system where the only thing in solution was the magnesium and the hydroxide salt, but we already have magnesium nitrate in there. So we don't really have this condition where we're dealing with X. What we have is a magnesium concentration that's going to be very close to 0.059 molar. Now, is it going to be exactly that? No, it's not. We have an equilibria shift to the left for this equilibria. Magnesium hydroxide solid produces magnesium ions and 2 moles of OH minus, but we have a Le Chatelier shift to the left. So the concentration is actually going to be a little lower than 0.059. It's going to be maybe 0.05899999999, but we're going to say that the difference between that and 0.059 is negligible. When I went through the problem, I set up the KSP. Normally the KSP would have been X times 2X quantity squared. Ooh, I notice I screwed this up. It was OH minus squared. Anyway, but we already know the concentration of the magnesium. And so we solved the rest of it. And then the bell rang and I said that X was 5.1 times 10 to the minus 5 molar, which X was, and it didn't match the answer that they had. You guys left, and then I realized, here's my mistake. X is not the OH minus concentration. 2X is equal to the OH minus concentration, which means that we would have 1.2 times 10 to the minus 5 molar. My answer being a difference in sig figs than their answer and the way they calculated it. But I wanted to clarify that.